Hello everyone, this is oral presentation number 3. My geological time period I was assigned was the Triassic period. The Triassic period is this very transformative period as far as periods go. The reason I call it transformative, it followed the largest mass extinction of plant and animal life ever to occur in Earth's history, which is the Permian extinction. So a little bit information on the Triassic. It lasted from 251 to 199.6 million years ago, so in between that time range. So a lot went down as far as like recovering from the Permian extinction. So I'll just go into talking a little bit about the life. So the Permian era was really known for its vast marine life, and the Permian extinction wiped out 95% of this marine life. And they've still debated on why the Permian extinction occurred, but as far as the oceans go, we know that this huge wipeout was caused by extremely high CO2 levels in the oceans. We know most of the fish and other marine life were totally knocked out by this extinction simply because the fossils that we have from the Triassic period from the oceans, they're relatively uniform. The fish and different marine life, they all look like they belong to the same family and that kind of thing. So there's not a whole lot of diversity. Something to come out of the Triassic as far as marine life, stony coral first appeared, and so this allowed for the first primitive reef building to occur in coastal regions, like shallow coastal regions and shallow parts of the Tethys Sea, which I'll go on to talk about in a little bit. An interesting animal organism, whatever you want to call it, that came out of the Triassic. It had survived the Permian extinction. It's called the ichthyosaurs, and it was a lizard-like tetrapod that lived on land at the beginning of the Triassic period, and then during the Triassic period moved to the seas, evolved by the end of the Triassic period into this 50-foot long, 30-ton sea predator that was just extremely dominant in the oceans. Talking about other types of life, new plants and insects came into the Triassic period. Really, for plants and insects, it was just a time of recovery. The insect group that survived the Permian extinction, they're arachnids, so that includes like spiders and scorpions, and then also millipedes and centipedes survived. I guess there was one new insect to the Triassic period, and that was the grasshopper. As far as plants go, again, they were just really trying to recover from the Permian extinction. Gymnosperms had survived in small numbers from this great extinction, and they had, during the Triassic, begun to get a foothold and start forming conifer forests once again. Also, during the Triassic, around the coastal regions, again, there was a kind of moss and primitive algae growth as well. So going on to reptiles, this is a big subject for the Triassic period because the Triassic is the first period in the Mesozoic era, and the Mesozoic era is known as the Age of Reptiles. So really, the Triassic is when the first foothold for reptiles happened. The two survivors from the Permian extinction would be the therapsids, which are a mammal-like reptile, and then the archosaurs, which are the more reptilian reptile that we would think of. The therapsids ended up going extinct about mid-Triassic period, but they were very important because before that happened, they gave way for the very first mammals to come out during the Triassic period. And these mammals were just small, shrew-like animals, probably nocturnal, lived underground, that sort of thing. But the archosaurs didn't go extinct. These would be the ancestors to the dinosaurs. They were extremely dominant during the Triassic period, mainly because of their ability to withstand the Triasic's climate, and we'll go on to talk about that. Jumping right into like geology and tectonic plate-like events that happened during the Triassic, the main thing that people think of when they think of the Triassic would probably be the formation of the supercontinent Pangaea. So sometime in between the Carboniferous and Triassic period, we know that all the two major supercontinents at the time had come together to form supercontinent Pangaea, and Pangaea was this C-shaped supercontinent, and in the middle it had the Tethys Sea, so kind of forming the sea with the Tethys Sea in the middle. Um, and so we know it, like I said, before the Triassic, it had kind of come together, and then about mid-Triassic, it had started to split back apart again. And it's for this reason that a lot of geologists will say that, relatively speaking, the Earth's crust was pretty dormant and inactive during the Triassic, because it was a slow, just coming together and then just coming apart. So not a lot happened geologically. I did read that the Sierra Nevada mountains did get their start during the Triassic period, though, due to some of this tectonic plate movement. So you ask, like, how do we know that this had formed and had split apart? Well, I was reading, and I guess paleogeologists use these things called polar wandering curves. And these polar wandering curves basically plot a relationship between the Earth's magnetic poles and their location to the supercontinents. And so with this, we were able to get information about basically confirming that, between the Carboniferous and Triassic period, that the Africa and America had conjoined, Africa and North America, that is, and then during the mid-Triassic period, they had begun to split apart. So it's through this like kind of advanced use of magnetic poles that we figured that out. I should talk. Pangaea did begin to split. It was a sea life, so it did split at the Tethys Sea. The Tethys Sea was kind of the zipper that split it apart into northern and southern hemispheres. The northern hemisphere was known as Laurasia, and this was a combination of North America and Eurasia. And then the southern hemisphere part would split into Gondwana, which is Africa, South America, India, Antarctica, and Australia, all combined into one. But they wouldn't totally split apart until the mid-Jurassic. So really during the Triassic, it was, for the most part, just a big supercontinent. And this big supercontinent really is the explanation for the climate during the Triassic period. So the climate during the Triassic period, well, over the mid-continent, as you could probably guess, it was very arid and dry. This led to very, very hot summers and very, very cold winters. But towards the coastal regions, the climate was more tropical. It was definitely warmer because there weren't any ice caps at either of the poles, on the supercontinent. So overall, it was probably warmer than it is today. But like I said, the tropical regions were on the coastal regions and around the Tethys Sea, and the reason these were tropical just because they were close to the moisture. They were held more temperate by the big oceans or big seas. So people will ask, well, how do we know what the climate was? And for a while, this was a big dilemma. There was all this evidence pointing towards a global climate of being very arid and dry. We have all this mud cracking from the Triassic period, as well as very few plant and animal fossils towards where the middle of Pangaea would be from the Triassic period. So we know that area wasn't very hospitable for life, so not too many plants and animals were able to thrive in the middle. But then again, we have all this other evidence, even in the middle, of monsoonal rains, seasonal rains coming. And this evidence is things such as like clay delta areas, where there's large clay deposits, as well as alluvial and fluvial riverbed kind of areas. So just indicating large amounts of flow of water during the Triassic. So we were able to come to the conclusion eventually that equatorial winds were able to bring moisture across even the middle of the continent, in these monsoonal seasonal rains. But then for the most part, the middle of the continent was very dry, hot summers, cool winters, and then the outside edges and around the Tethys Sea was very tropical and experienced a lot more rain. Another indication of like kind of those tropical regions that we know, during the Triassic, they had to be extremely tropical because of the large amounts of coal deposits we have. Basically, coal is formed from decaying plant matter, basically sitting on top of itself. And a lot of times we think of coal being formed in swampy areas, so areas of rich vegetation and then low water drainage, so indicating monsoons. So that's how we draw the conclusions about that. But that looks like all the time I have. I hope I covered everything excellently. Have a great day, guys.